questions 21 to 25 on the 2005 Grade 8 Gauss Math Contest. In the diagram, a circle is inscribed in a large square and a smaller square is inscribed in the circle. If the area of the large square is 36, the area of the smaller square is. So here is our diagram, and let's see what we can do. First thing I'm going to do is draw a line from the center to the corner of the square like that. And then I'll draw another line I should say, from the center till the edge of the circle. All right? Now those two lines represent what? They represent the radius of that circle. There's only one circle in this diagram. Now, another thing I need to label is this part of the square right there in blue. That's x. And because of the symmetry of this diagram, this is also going to be x, because that line that I drew in green cuts that in half. And in a very similar way, if you were to draw another line that goes across like this, like that, that would also create a value of x for this distance right here, from here to here. And very similarly, that's x, and this is x. We just created a box or a square with x's all around. And this distance represents the radius, so I'll just call it r for radius. Now I hope you can see a Pythagorean relationship there. I can use this triangle right here and use the Pythagorean formula. So that means x squared plus x squared is equal to r squared, like that. So 2x squared is r squared. Now they give a very important clue in the question that the area of the large square is 36. If the area of the large square is 36, that means that this side is 6. Right? That's the only way you can get the square to have an area of 36. And that means this side is 6, the large square. Now, what's important to recognize is that if that's 6, then what's this distance from the center down? That distance is 3, so that essentially means that r is 3, correct? Because from here all the way down to here is the radius of that circle. So there we go. Plug that in there. We got 2x squared is 3 squared, like that. And therefore x squared is equal to 9 over 2. Now what do they want in the question? They want the area of the smaller square. All right, well the smaller square, its side length is 2x. So its area will be 2x all squared. So that's 4x squared. So 4 times x squared, and x squared we just figured out was 9 over 2. And there you go. So that would be what? 2 times 9, 18. So number 21, the answer is E. 50 students were surveyed about their participation in hockey and baseball. The results of the survey were 33 students played hockey, 24 students played baseball, 8 students played neither hockey nor baseball. How many of the students surveyed played both hockey and baseball? So we've got what you call a Venn diagram, and don't freak out. Don't think, oh no, I don't know what a Venn diagram is. It's okay. I will explain it as clearly as I can. So, here we go. All right. So the green circle represents all the people who play hockey. All right? And the blue represents all the students who play baseball. And then this region in the middle here, which sort of is like right there, that represents, I think you can kind of figure that out, who play both hockey and baseball. And that is exactly what we want to figure out. So I'll call that region B. And then the other two regions I'll call A, and we'll call it C. Why not? Now this question, they give us a lot of important clues. The first thing they tell you is that 33 students play baseball. Play hockey. 33 play hockey. All right, so that basically means that A plus B is equal to 33. The next clue is 24 students play baseball. So that means that B plus C is 24. And 8 students play neither hockey nor baseball. Now 50 students were surveyed, so out of the 58 don't play either sport, so that means 42 are left. This diagram involves 42 students. Okay? So that basically means that A plus B plus C is 42. And I think that's all we can get in terms of our equations. Now, they want us to figure out how many students played both hockey and baseball. So find B. All right, I think that's pretty straightforward using this equation. Well, A plus B plus C equals 42. Okay. But we know that A plus B is equal to 33. So just substitute that in there. 33 plus C is equal to 42. So therefore C is 42 minus 33, which is 9. And then I can substitute the value of C equals 9 into that equation. B plus C is 24. And that would give me B plus 9 is 24. And therefore B is 15. So this is 15, this is 9. And if you use any of these equations to get a value for A, you'll get A is 18. But we were only asked to figure out B, which is 15, and therefore number 22, the answer is D. A wheel with radius 1 is rolled in a straight line through one complete revolution on a flat horizontal surface. How many meters did the center of the wheel travel horizontally from its starting location? Okay, let's draw a little diagram here. We've got one circle and then the exact same circle. Something like that. And we are asked essentially to figure out the distance from the middle to the middle, like that, as this wheel or circle, it's a wheel actually, moves along. So that red line is what they want you to figure out. Well, this question basically says that the wheel is turning one complete revolution. So that means that along the floor of the, what are they calling it? Flat horizontal surface. Flat horizontal surface. It's going to travel from here and then eventually end here. Now that distance represents one complete revolution. It represents the circumference, C. So the answer to this question is C. But those are not represented in the answer choices. We want an actual numerical value. The circumference is how far this circle will travel. Well, we know that the circumference is equal to pi times diameter. Diameter is 2 times the radius. And the radius they give you is 1. So there you go, 2 pi. And that's it for number 23. They gave you a little bit of a break on number 23. So the answer is C. Pete is given 3 positive integers and is told to add the first 2 and then multiply the result by the third. Instead, he multiplies the first 2 and adds the third to that result. Surprisingly, he still gets the correct answer of 14. How many different values could the first number have been? I'll let the numbers be A, B, and C. Now, he is told initially to add the first 2, A plus B, and then multiply the result by the third number. But instead of doing that, what he does is he multiplies the first 2 and adds to that the third. But both times he gets 14. And we are told, how many different values can you get for a, the first number? All right, let's work with this here. From the first equation, I've got a plus b times c is 14. So c would be 14 over a plus b. From the second equation, this guy right here, I've got ab plus c is equal to 14. So that means c is equal to 14 minus ab. Correct? So now I can set these two equal to each other since they are both equal to c. So 14 is equal to 14 over a plus b is equal to 14 minus ab. Okay? And then I'll just cross multiply 14 minus ab and then a plus b like that. Okay. Now at this point you're thinking, well, geez, where do I go from here? I've got two variables. How do I solve this? Well, you make a little table. And this is one of those questions that it's pretty cool. You know, you'll be able to see how this kind of works itself out. And don't freak out because you think, well, I only have one equation. I've got two variables, I've got one equation. I can't do that. Normally, right, the answer is you couldn't, but you can with inspection. And I'll show you how. So this multiplied by this gives you 14. We are told that a, b, and c are integers. So that means a plus b is an integer. And 14 minus a times b is also going to be some integer number. Okay, well, how do we get 14 if you multiply two integers? Well, we've got a few choices, right? First, I'll write 14 minus ab here. And here I will write a plus b. These two, one multiplied, have to equal 14. How do I do that? Well, 14 and 1, that's one possibility. 7 and 2, 2 and 7, and 1 and 14. These are possibilities. I'm not saying these are going to work because we're going to have to get a and b to be integers. If you don't get an integer value, a positive integer value, I should say, then it's not going to work. Well, let's see. Let's do the first one. 14 minus ab is equal to 14. Okay? And we've got a plus b is equal to 1. Well, from the first one, I can notice that would mean ab would have to be equal to 0. And that obviously doesn't work, right? Because a and b are both positive integers, so neither one can be 0. So this is a dud. I'll just put an X there. That doesn't work. No problem. Let's keep going. Let's try the next one. We got 14 minus ab is equal to 7. So that means that 7 is equal to ab. Okay? So if 7 is equal to ab, that means we can let 7 over a equal b. Now we go to our next criteria, which is a plus b. A plus b is equal to 2. So a plus 7 over a is equal to 2. Can we get this to work? If a is 1, it'll be 7 plus 1. That doesn't work. And if a is 7, then this is going to be 1 plus 7. That doesn't work because a has to be an integer. So there's no way of getting this to work, actually. This will not be able to give you a value for a, and definitely not an integer value. So that's a dud. All right, don't give up hope. We still got a couple more. How about if 14 minus ab is equal to 2? All right, this looks promising. ab would therefore be 12, and we can isolate b 12 over a, like that. So then we've got to fill this criteria. A plus b is this time 7. So we've got a plus 12 over a is equal to 7. And by inspection, you don't have to do a quadratic. You'll be able to see that if a is 3, this will work. It'll be 3 plus 4. So a is 3. And therefore, b in this case is 4. All right, so we got one possible value for A. And then we got one more. 14 minus AB is equal to 1. And that means AB is equal to 13. And B is equal to 13 over A. Now let's use that one. A plus B is equal to 14. A plus B, which is 13 over A, is equal to 14. And again, by inspection, if A is 1, this will work. If A is 1, this becomes 1 plus 13, which is indeed equal to 14. And therefore, B is 13, like that. All right, we got another one. So I've got two values for A. I've got 3 and I've got 1. All right, let's see. Well, 2 is not one of the answer choices. Ooh, okay. Well, what did I do wrong? I don't think I did anything wrong. I just have to understand that these can flip. This table can be done in the exact same way with this being B and that being A. So I'll let you do that, but it's identical. And if you do that, you'll get values of A as 4 and 13. So A can be either 1, 3, or it can be 4 or 13. All right, I hope that makes sense. So I got 4 values, and that is definitely part of the answer choices. So number 24, the answer is B. A purse contains a collection of quarters, dimes, nickels, and pennies. The average value of the coins in the purse is 17 cents. If a penny is removed from the purse, the average value of the coins becomes 18 cents. How many nickels are in the purse? So we got pennies, nickels, dimes, and quarters. So the number of pennies times 1, which is the value of a penny, plus the number of nickels times 5, which is the value of a nickel, plus the number of dimes times 10, plus the number of quarters times 25, is the total sum of the amount of money. And of course you have to divide by the number of coins, which in this case would be the number of pennies, plus the number of nickels, plus the number of dimes, plus the number of quarters. And they say that when you do that, you get 17 as your average. All right, so that's your first equation. I'll multiply this out, and I'll get P plus 5N plus 10D plus 25Q is equal to 17P plus 17N plus 17D plus 17Q. And putting everything on one side, you'll get 16P plus 12N plus 7D minus 8Q. Okay? And that's equal to 0. And I think that's about as far as we can go there. Now let's take into consideration the next piece of information in the question. If a penny is removed from the purse, the average value of the coins now becomes 18 cents. So exactly what we did here, but instead of P, it's P minus 1, right? Because 1 penny has been removed. Everything else is the same. 5N, 10D, 25Q. And then the denominator, this time, we have 1 less coin. So it's P minus 1 plus N plus D plus Q. And that, they tell you, is equal to 18 cents. Okay? So this becomes, let's see here, P minus 1 plus 5N plus 10D plus 25Q. And that is equal to 18P minus 18 plus 18N plus 18D plus 18Q. All right, let's put everything on one side. 17P plus 13N plus 8D minus 7Q. And then, let's see here, minus 18 plus 1, so minus 17 equals 0. All right, I got two equations. I'll call this equation 1. I'll call this equation 2. Now I've got to combine these because both of these conditions have to hold true. How do I combine them? I'll just do 2 minus 1. I think that will allow me to at least get rid of one variable, or maybe not. Well, we'll see. Or maybe it doesn't help me at all. Who knows? Let's say 2 minus 1. I've got to combine them somehow, though, because otherwise they wouldn't give both pieces of information in the question. 2 minus 1, let's see here, P plus N plus D plus Q minus 17. All right, that looks good. I like the way that looks. So that means that P plus N plus D plus Q is 17. So that means there's 17 coins. Okay. That works out pretty decent, I think. Now we have to figure out how many nickels. All right. All right, so I think at this point, because there's so many variables, this has got to be done entirely by inspection. Because if you have 4 variables, you would need 4 equations to figure out each variable. All right, so let's make a little table here. Hopefully we don't have to rack our brains too long to figure out the answer. Okay. All right, so we got 17 coins. And we know that the average of these 17 coins is going to be 17. So that basically means that if I take the sum of the value of the coins, which would be P plus 5N plus 10D plus 25Q, and divide by the number P plus N plus D plus Q, that average is 17. All right? That means P plus 5N plus 10D plus 25Q is going to be 17 if you cross multiply times this, but that we know is 17. So it'll be 17 times 17 like that, which is 289. So I've got to figure out, how do I get a sum of 289 if I use pennies and quarters and dimes and all that stuff? Okay, well, the first thing I notice is that everything is a multiple of 5, right, except the pennies. Quarters, dimes, and nickels are a multiple of 5. But I've got 289, and that's not a multiple of 5, so I'm going to subtract 4 pennies from that. So I'm going to let P equal 4. And if I do that, that means I've got 285 cents remaining that I've got to make with the nickels, dimes, and quarters. Now, it shouldn't be that hard to figure out how to do that. How about if I use a whole bunch of quarters? If I use, say, I don't know, if I get close to that, 275 would be, what, 4, 4, and 3, so 11 quarters. 11 quarters would bring me to 275. So that means I've got 10 cents left. I can make 10 cents with 2 nickels. All right, that is definitely true. But I've got to figure out this in a way so that my coins equal 17, the number of coins. Let's see. 4 pennies, 2 nickels, 11 quarters. That is 6 plus 11. That is 17 coins. Great. I think I've done it without too much pain and suffering. So there you go. We've got 4 pennies, 2 nickels, 0 dimes. Yeah, 0, I'll put a 0 in there for dimes, and 11 quarters. And what they wanted us to figure out in this question was the number of nickels, and that's 2. So therefore, number 25, the answer is A.